Hello, geometry class. I thought I had one of these on recording, and I did not. So this is current for you. Don't mind the background noise. I have the draft on in the background, just in case. But it's on low, so hopefully you can't hear it. So let's get started. We're going to do the review. I did, again, come up with some extra problems for practice. So I hope that is helpful and that you stay tuned to pick them up, these extra problems as they arise in here. Okay? So first thing, draw a net for each figure. Label this net. Okay. So we need to make sure, when I said to do it, these are both prisms, right? They're both actually triangular prisms. And I said when you do prisms, it's easiest for the nets if you do the rectangles first. So there's going to be the 3 rectangles. And I'm not so much looking to see if they're perfectly drawn to scale or anything, but I should see the 3. I mean, they're pretty close in size. But then we have a triangle, but it's not just any triangle. Do you notice what it is? It's a right triangle. So I'm going to actually do it like this. A couple different ways you could do it. And then I'm going to label it. So I'm going to make this my 3. And then the other side is a 4. Which then is going to make this side a 4. My hypotenuse, so my right angle's in here. My hypotenuse is 5, which is going to make this a 5. And then my height of the whole thing is the 6. And I believe we got it all labeled there. You don't have to put these in there, but you can if you want. Okay, now this one doesn't have a label, so it's a little easier. It's still triangular prism, so again, there's 3. And we can a little more easily throw those on there and be all done. Okay. Verify Euler's formula for this figure. So this is a prism. And then it also says verify for the net. So first thing, you got to make sure you get these formulas down right and not use the wrong one. So I'm going to write it, and then this one actually has it there already. And I'm trying to remember, let me look actually. Yeah, on the test they don't have it. So you will need to know that. So write that down somewhere for you to study, or highlight it on your paper to make sure you look at. I'm not going to give that one to you. And when I look at this figure, faces, how many faces? Well, it is, what kind of figure is this one? I gotta count. 1, 2, 3, 4, 5, 6, 7, 8. So we've got an octagonal prism. And how many faces? Well, I've got the 8 faces going around the 8 rectangles, and then the 2 bases, so that's 10. Plus the vertices. So I've got the 8 vertices here, and then the 8 up here. So I have 16 equals the edges. So I've got the 8 here, I've got the 8 here, that's 16, and I've got the 8 around. So the edges are actually 16, not 16. It always will turn out to be that way on prisms. It's actually 8 times 3. So you just get your 24 edges plus 2. So let's check it out. 10 plus 16 is 26. Is that equal to 26? Check. Then when we do the net, okay, so I gotta draw the net as it says right here first. So again, for a prism, there's 8 sides. So I'm gonna go make it a little longer. So 8. So I'm going to cut it in half, half, half. There's 4, and then half. I think that works. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so faces. Well, wait, I don't have my bases on here. Okay, I'm not real good at these, but 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, I'm going to get a different color. And you need bases. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Plus the vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Oops. Hope I counted those right. I don't think, let me just look. Yeah, the one on the test does not require extensive sides like this one where it's a little harder to draw. Edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. I think I screwed something up, but maybe not. We'll see. 10 plus 32 is 30. Oh, wow. Okay, no. Back it up. 42. Oh, I did do it right. Oh, good. Because I thought I might have counted wrong. Actually, my review sheet says it was 30, and I must have gotten wrong. 1, 2, 3, 4, 5, 6, 7. No. I'm looking at this right now to see what I counted wrong for the vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 30. No, I had something wrong here. I must have put too many edges on this. I guess that's better to count these first, because I would know there's 8 here and 8 vertices here. So that's 16, and then count these other ones. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Ah, I did screw it up. And then the edges should have been 39. Somehow I counted it wrong. Like I said, you won't have an octagon where it's harder to draw, therefore harder to count. So don't worry about that issue. It will be either a hexagon or smaller. Yeah, it is. I just verified. What is the number of edges in a prism with pentagonal bases? So pentagon, you got to know all those, right? Pentagon is 5 sides. And if it wants to know the number of edges, do you remember what happened here when we figured out edges? When you have a figure together, it was the 8, and then the 8, and then the 8 around. It was 8 times 3. That was for an octagon because there's 8 sides. If it's a hexagon, that's 6 sides. It'd be 6 times 3, 18. For a pentagon, there are 5 sides. So it's going to be 5 times 3, which is 15 edges. Describe the cross section for each. So remember, the cross section is if you cut through with a piece of paper horizontal, not horizontal, parallel to the bases. So I have to cut it perfectly parallel to these. So when I cut through, I'm going to get that same thing. So in this case, it's a circle. Here it's a little harder to see because I'm cutting through the vertice and perpendicular to the base. So I don't know if you can see this, but this is what you're going to end up getting here. That's pretty darn good. Triangle. So some things are more visually challenging to figure out. All right, number 8. It says a food company makes regular and tall soup cans. The area of the base of both cans is 10. The volume of the regular can is 60, and the tall can is 3 centimeters taller. Tell me that volume. Okay, so let's start with clear labeling. We have a regular and a tall. I need a new color. I'm bored with that one. Bored. Okay. So we have our regular and our tall. Organization is key as we get into more complicated problems. We're talking about volume of a soup can. So what kind of figure is that? That is a cylinder. So we need to talk about volume of a cylinder. We look on our formula sheet and make sure we get the right formula. Now, we are ultimately trying to find the volume of the tall can right here. That's our goal, and when we get this, we're done. So do we know the base and the height? Well, let's look back in here. It says the area of the base of both is 10, so we have that. So volume equals 10. The problem is we don't know the height. All we know is that the tall can is 3 centimeters taller than this one. So if I can't figure out the height from here, I can just add 3. So when I get this height, I want to add 3 to it, and then I'll have that one. So let's figure it out. If we can. The volume of the regular soup can is 60. Put that in for volume. The base of both is 10, so we have 10. And height. Well, isn't that nice? So solve for h. Divide by 10. H is 6. Okay, so the height of this one is 6 centimeters. And it says the tall can is 3 centimeters taller. So that means this height is going to be what? 6 plus 3 is 9, which is equal to 90 centimeters cubed. I hope that makes sense. Okay. Now to this fun page. Honestly, the key to this page, mostly, there's other keys, but make sure you get the right formulas and write them down properly. Okay? First of all. And then, of course, you will have to deal with some Pythagorean theorem multiple times. I think there's 3 times just on this page, and I believe it's the same for the test. I think there's at least 3 times you need to use Pythagorean theorem. So let's get cracking. I'm going to kind of not cruise, but move consistently through this. So when I look at this figure, the first thing I know is it is a box, or it is also a rectangular prism. I would use the box formula, which is surface area equals 2LW plus 2LH plus 2WH. It might be in slightly different order on your note sheet. Just stands for length and width and height. So here we go. So decide which one you're going to make what. It doesn't matter. They're interchangeable. Length, width, height. I label them so I don't accidentally substitute the wrong 2 in. So I got 2 length times width plus 2 length times height plus 2 width times height. And I'm going to relook at it because I shouldn't have the same combo here. 8, 7, 8, 6, 7, 6. So it should be a combo of each. So do each of these first, and I get, let's see here, 56 times 2 is 112 plus 48 times 2 is 96 plus 42 times 2 is 84. I add them together, and it's 292 meters. It's an area, should be squared. All right, next, volume, and that is simply length times width times height. So my length was 8 times my width, which was 7, times my height, which is 6. Again, you could have chosen, they're all interchangeable, so you could, length, width, and height can be anything. When I multiply them, I get 336 meters, and now it's cubed because it's volume. And surface area of what? Look in your figure. You look at your figure, you say, okay, I got a cylinder. I change color. And when I do that, I need my proper formula, which is 2 pi RH plus 2 pi R squared. And then I need to look on here. The only items I need to complete this are my radius and my height. My radius is very clearly a 5. If you're unsure ever on a test, like if it's the whole length of something and you're not sure, is it radius or is it all the way across, you can just ask me. I'm happy to clarify. And then here's my height. So plug them in. Equals 2 pi times 5 times 7 plus 2 pi times 5 squared. And again, you do this first, and then you do this, and then we add. 35 times 2 is 70 pi plus, make sure you don't make the fatal mistake of doing this and saying it's 10. It is 25 times 2 is 50 pi. 70 plus 50, 120 pi's. I need to go up and remember what's happening here. And I see that it is rounding to the nearest 10. So I grab out the calculator. I do not abbreviate along the way or my rounding will be off. 120 times the pi button is equal to, can you see it on there? It's 377.0. Okay then. That, oh, 7, I wrote it wrong. I'm so excited I wrote it wrong. 377.0. Yes, yes, and yes. You have to have it. It's still a place value. And it is inches squared. It tells whoever's reading it that you went to that place. That also means that I need to go up here and adjust these. Because these came out even, but if we are still rounding to that place, I'm going to round it. No, not sure I would actually, whatever. Next, volume. Pi r squared, height, is volume of a cylinder. I make sure I get the right formula. Pi times radius squared times height. That's 25 times 7 is 175 pi. I plug it in the calculator. 175 times pi, and it's 549.8. Cubed, because it's volume. And you know what I'm going to do is when I'm done with this page, I'm going to double check this to make sure I don't forget anything. Look at the next picture. Analyze. What is it? It's a, well, square, because actually I can see these sides are all the same. So it's a square pyramid. And I get the right formula for square pyramid for surface area. I'm very careful to double check and make sure I am not copying the wrong formula. And I'm going to actually put in just the lateral area as well right now. So lateral area is 1/2 perimeter times slant height plus area of the base, which in this case I said was a square. So I'm going to put that in there. So let's get the things we know for sure. Perimeter. Okay, if the one side is 7, that means all of them are 7 because of the markings. So that's 28 for the perimeter. It's the distance around. Slant height, nice, we have it. They gave it to us. It's 7 plus side squared. Okay, so that's 7 to the second. So 1/2 of 28 is 14 times 7 is 98. Plus 7 squared is 49. That comes out to 147.0 centimeters squared. Volume. Pyramid. 1/3 capital base times height. Again, what is the base? It's a square. Area of a square is side squared times height. So 1/3 times 7 squared times height. Do I have height? I do not have the height. Okay, I gotta get it. The height goes straight into the middle and over. Very interesting. Looks like a right triangle to me. It looks like we might need to use Pythagorean theorem because this is 7 all the way across. So this to here is 3.5. And I need the height. So I'm going to jog off to the side. Remember, the hypotenuse is the one alone. So I have h squared plus 3.5 squared equals 7 squared. H squared plus 3.5 squared is 12.25 equals 49. Subtract the 12.25 from both sides. H squared equals 36.75. And then I'm going to square root that. So h is equal to the square root of 36.75. Notice I'm not pushing the button. I'm going to leave it in the calculator for now, but I'm not going to round that. I don't want a mistake, so I'm going to go back here and put this in. Square root of 36.75. Okay, so now we got to figure that out. So the rounding matters. So I have it in my calculator. So now I can push square root button, and there it is. Okay, that's an estimate. I'm not going to clear it. I'm going to leave it in there, and I'm going to multiply it by the 7 squared, which is 49, times 1/3, which is the same as what? Multiplying by a third is the same as dividing by 3. Divide by 3, 99.0. What's our unit? Centimeters cubed. I wish I would have sealed the deal here. I don't like it like that there. And I should do the same thing above, but I won't waste your time doing that. All right, next thing. I look, I say, oh, I've got a cone. I look at my paper, I get a cone formula out, and I write it properly down. I double check to make sure it's accurate. Pi radius slant height plus pi radius squared. And I'm going to do pi radius. So the radius here, because they're pointing directly at this part right in the middle, then I'm going to say this is the 10. Again, if you're not sure, please ask on the test. That's not supposed to be something you have to guess at. Slant height. Yay, we have it right here. It's 11. It's a slanted height, right? Pi times radius, again, that's 10 squared. Equals 10 times 11 is 110 pi plus 10 squared is 100 pi equals 210 pi. It is only now that I will grab my calculator, because if you've been rounding along the way, you'll likely have it rounded wrong at the end. 210 times pi equals, nearest tenth, 659.7. And it is millimeters, it's area, so it's squared. Onward, the volume, going to go to volume, it is 1/3 pi r squared. So now we're going to go ahead and all we need is our radius. So 1/3. Oh, I forgot something. See, I was double checking my formula and voila, forgot the height. So it's always double check. Times the radius, which is 10 squared, times the height. Uh-oh, that's what I don't have. I only have slant height. So I'm going to go ahead over here and I'm going to draw in my perpendicular and go, yay, I can do Pythagorean theorem again. So I need my height. Height squared plus 10 squared equals 11 squared. Height squared plus 100 equals 121. minus 100 from both sides. Height squared equals 21. Height is square root of 21. Again, I'm not going to plug it in right now. I'm just going to go over here and write this down so I have it. I can do 10 squared. That's 100. That comes out nice. And square root of 21. I'm going to grab the calculator and I'm going to do the 21 square root times 100. So there's no adding or subtracting, so I can do it in any order I want. Times pi times 1/3. There is that fraction key, so if you want, you can use it. It's right down here. So you could, I'll show you that. 1/3. And there it is, 479.9. And it is millimeters cubed because it's volume. Again, I want to show you if you did this way, times 100 times pi. I can also divide it by 3 and I'll get the same answer. So you can use fraction key or just know that when you multiply by 1/3, it's dividing by 3. All right. Okay. One different color. I'm going to do surface area of what figure is this? Triangular prism. Okay, that is the same exact color. Do not want that one. I'll use pink. I'll do pink. Surface area for a prism. Make sure you get the right formula. It's LA plus 2B. So lateral area for a prism is perimeter times the height of the prism. So I'm going to substitute that in. So I have that. And then the area 2, and then area of the base. So we've got a base here that's a triangle. So how do you get area of a triangle? You have to know that. Area of a triangle is 1/2 little base times height. Okay, so don't get mixed up. Right now, though, I can see that when I'm multiplying these, what's 2 times 1/2? Yeah, they cancel out, don't they? So I'm going to do that to make it look simpler. Little b times height. So let's go in here and get the perimeter first of our base and multiply it by the height. I don't know if we can get the perimeter, can we? Let's see. Oh, yes, we can. Because, look at this one, I was looking at the base, and I'm thinking of perimeter, and I'm like, okay, 19 plus 18, and I'm like, shoot. Oh, but I got it right here. So that's 18. So 18 plus 18 plus 19 is 55. Times the height of the prism. Remember, that is the distance from the front triangle to the back triangle. Right here. Well, I have it right here. 22. That's the height of the prism. So I'm going to put in a 22 there. Now back to this triangle, because that's what the little base and height is the area of the triangle. So do I have the base of the triangle? Yes, it's 19. But do I have the height of the triangle? No. You need to do Pythagorean theorem for that. So when you look at this, notice we got to find our triangle, and it's right here. Okay, there's my triangle. And then I'll just multiply, well, I won't multiply by anything. I am getting the height. So height squared plus this. What is that? It says these are the same, but the whole length is 19. So half of that would be, oh, sorry, I'm distracted by the TV. It's still going to be a while, though, I think. It's still early in the draft. Anyway, sorry, distracted. Okay, half of 19 is 9.5 squared equals the hypotenuse, which is 18 squared. And then we just need to solve. So 8 squared, 9.5 squared, 90.25. 18 squared, 324. h squared, subtract the 90.25, both sides. 233. I like the way I did that. Square root both sides, and there's our height. Square root of 233.75. Okay. Now, 55 times 22. I'm going to do that first. Get that done. That's 1210. Plus, I need to get that bad boy. So 233.75. 233.75. I'm going to square root it. Then I'm going to multiply it by 19. And it's about 290 whatever. I'm not going to clear it out though because that's this. And I still need to add the 120. So I'm going to add that 120 now. I can put about 290 in here if that helps you. Plus 120, and it comes out to 410. No, sounds wrong. I wrote something wrong. Yes, I did. This is not 120. This is 1210. Let me try that again. Sorry. Square root of that times 19 plus 1210. There we go. 1500.5. Centimeters squared. All right. Sorry, that's coming off the screen. Let's get focused here and make sure I'm on the screen. All right, so volume for a prism is pretty simple. Area of the base times the height. So, area of the base. The base is that triangle again. 1/2. The base is 19 times the height, which was what? Right here. Times the height of the prism. So remember, this whole thing, that was their area of the triangle. 1/2 of the area of the base of the triangle times the height of the triangle. I'm only looking at the triangle. Times the height of the whole prism from here back to here. It's 22. And let's do that. 233.75 square root times 19 times 1/2, or divide by 2 times 22. And there we go, 3,195.4 centimeters cubed, because it's volume. Okay, then we're at our pretty easiest one to figure out, honestly. It's the sphere. And we need surface area of a sphere, which is only requires one thing, 4 pi r squared. So that is the radius right here, 11. 4 pi. Just make sure if they give you the diameter, you split it in half. 11 squared is 121. It's 484 pi, which is 1,520.5 inches squared. Remember, there's no lateral area for this because there's no bases. Volume 4/3 pi r cubed. It's the most commonly miswritten formula ever. Everyone puts a 2 in there. I don't know why. I think it's because of that too. So volume equals 4/3 pi r is 11 cubed. And I'm going to go in here and do that on here. So 11 cubed, so I have 11. You can do 11 times 11 times 11, or you can do 11 and use this button right here. And then 3. So that's that. And then times 4/3. So times 4/3. And then times pi. 5575.3. I want to show you something though. So that works out just fine and dandy because I said to round. But how would you do a problem like this if it said to put it in terms of pi? And I'm going to show you that. So 11 to the third was this. So if it was 4/3 pi times 1331. Okay, so let's say you had that because you did 11 to the third and got this. I need to leave it in terms of pi, so I don't want to multiply this and get an approximate. Okay, if I multiply this by 4, I get that. No, that's not. That's rounded now, right? It goes off here forever. It repeats. So instead, I'm going to leave it as a fraction. I'm going to make sure, because this is really over 1, I'm going to make sure this doesn't divide by the 3 in the bottom. No, it doesn't. So therefore, I'm going to multiply the top times 4. So it'd be 5324 over the 3 pi inches cubed. That's how you would write that. You would just leave it as a simplified fraction. Like you can't, I don't think so, 8. No, we would know it. Wait. Yeah, that's 14 when you add them up. That you can't divide it by 3. So we're done. Good. That's a little bit of the grueling page. Not that it's that hard. It's just you gotta be, what's the word? Relentless and tedious with it. Okay, the volumes of two similar figures are 972 and 36. The surface area of the larger is this. A, what's the scale factor? And B, what's the surface area? So look at right here, they're asking for a surface area. Here it's scale factor. So they're not actually asking you to figure out something about them. They're trying to figure out that ratio, side to side, length to length. Okay, so remember I said it's kind of helpful if you just kind of view it as, you got your length, you got your area, and you got your volume. And it's kind of like your x, and your x squared, and your x cubed. And you're kind of moving on this continuum. So let's see what we have. We have volumes, which puts us in the cubed range. So 972 and 36. So first of all, you want to see if that simplifies. So let's try it. 972 divided by 36 is 27. Nice. Okay, so that's actually 27 over 1. But if we're trying to, first of all, answer scale factor, that's this ratio over here. Length is scale factor. So I got to get back to here. So how do I go from here and get back to here? That's right, you would take the cube root of x to get x. So you're going to take the cube root of this. What's the cubed root of 27? 3. What's the cubed root of 1? 1. So we got a 3 to 1 scale factor. You can write it like that. You can write it like that. Now it said what actually is the surface area of the smaller one. Well, they have to give you one of them. But before I do that, I need to get this ratio. Because if they're asking for area, I need this ratio. Okay, so if I have x, how do I get to x squared? Well, of course, I square it. So 3 to the second and 1 to the second is 9 to the 1. So now I'm going to go over here and set up a proportion. I got my 9 to my 1, my area. I needed that. Equals, and I'm going to look at which area they gave me, the bigger or smaller. So the surface area of the larger. So larger tells me it's going to go on the top over here next to the larger one of these two, is 594. And that's what I want to find. And now we just have a straight up proportion to solve. You just had to get these figured out first. It asked you for this one, and then you needed this one for the second. So of course you cross multiply, divide. What is that? 66 centimeters, and it's area, so it's squared. Okay, circumference of a standard bowling ball is 27 inches. Okay. To the nearest unit, how many square inches is the surface area of the bowling ball? Hang on a second. You know what I just realized? Not to totally distract, but I forgot, and I'm going to do it while I think of it, to check to make sure I did everything to the nearest tenth here. So I'm just going to go through and make sure it's all point something. Okay. All right, we're good. Just remember that. I forgot to do that. So back to this. We're looking for surface area of a bowling ball. A bowling ball is a what? It's a sphere. So I'm going to do surface area for a sphere. 4 pi r squared. Great. This is a simpler formula. All I need is the radius. The problem is what? They didn't give me the radius in here, but they gave me something so I could figure out the radius. Okay, so they told me what is 27. Circumference is 27. So you need to remember, what was circumference formula? We had two that we could use. 2 pi r was one, and pi times diameter, same thing, right? Because 2 r's equal a diameter. So I'm just going to use, well, it doesn't matter, I can use either. Circumference equals 2 pi r. They told you the circumference, so substitute that in. Now all I have left is my r, yay, because then I can put it in here. You can divide by the 2 pi at the same time. 27 over 2 was 13.5 pi. I'm leaving it, okay, because it said to the nearest unit, so I don't want to start rounding earlier than I should. So I'm going to take this, and I'm going to go up here and put it in for my r. SA equals 4 pi, 13.5 pi, use your parentheses, squared. Now, let's grab a calculator. Okay, we're going to start in the parentheses. 13.5 divided by pi button equals. Okay, so I got the inside the parentheses. Now I'm going to square it. Now I'm going to multiply it by pi. Now I'm going to multiply it by 4 and push equal. And it looks like it's 232 inches squared. I think I missed something else major here. Did you guys see that? It asked for the surface area of 100 bowling balls. So I should have very prominently put this up here so that I did not forget that I got to take this answer, leave it in the calculator, and multiply it by 100. And then round to the nearest whole, which is this value right here. So I'm looking at the 7, I'm saying round up to the 5. So 23,205 inches squared. Okay? So write up your page and circle things up and highlight. I wish I had a highlighter with me right now. Oh, I do. That's silly me. This bright pink one. Yeah. That didn't help me too much, did it? Now that I'm done. Well, actually, we're not done. We're going to do a couple more problems just for practice. So There was something else so I noted on my review that I don't think I went through. Let me look where that was. Oh yeah, I was going to ask you this. Back here on the first page, when we had this one, I wanted to ask you what you would get if you did a vertical. If you cut through this vertically, what would you get? What cross section would you get if you went vertical? Think of an answer. Should have said rectangle. If you cut across here, it would go straight down like that. And you're going to actually end up with a rectangle. What, if you had multiple of these, like you said this one right here was a circle. Let me erase this. You said this was a circle. What's true if I do multiple ones here? What are they? They're all circles. What kind of circles? They're congruent circles, right? They're exactly the same. Is that the case when you have a cone? If you do a slice through here, what do you get? A circle. What are you going to get when you go here? A circle. But what's the difference between slicing these and slicing these? These give you a bunch of congruent circles, and this gives you a bunch of what? Similar circles, right? They're not exactly the same. These are similar circles. Sorry, I really am distracted because every time I hear that, that's a selection on the draft, so I keep looking up. Oh, heaven help me. Okay, similar circles. There's a tongue twister, whereas this one gives you congruent. All right, good. Then let me see if there's any other notes. Oh yeah, there was one more. This one, I wanted to ask you, if I had one like this, what would you do if it was an equilateral triangle? What if I gave you a triangle like this for your prism? Would you be able to figure out everything you needed to back here? Remember, because we had to figure out the area of the circle here and here. Would you be able to figure out the area of that circle? 1/2 base times height. You have the base is 5. How do you get the height? That's right. You can draw it in because it's equilateral. So you know it's 2.5. So you'd have height squared plus 2.5 squared equals 5 squared. And you would solve that. And that would be your height. Okay. I just want to point those things out. And now let's look at the extra problems for you to try. First up, I want you to draw, on the review, they only had, let me see, they only had triangular, right here, they only had triangular prisms, which I didn't think was a real good review for drawing. I wanted to make sure you could do a square prism and you knew how to draw pyramid as well. So pause the video, go ahead and draw these two, and then check with me in a minute. You can actually go ahead down here and do this at the same time. I want you to do Euler's formula for a pyramid, because we didn't try that. And then Euler's formula for the net of the pyramid after you draw it. So do those things, stop the video, and then come back, because I'm going to go over them right now, but I want you to try it first. Then we only have one other problem to do. Okay. So, as I said with the prisms, go ahead and get your rectangles down. It's a square, so there are 4 sides, and I need to label them. So I have a 3. What's the other side? What's this? It's 4. So pay attention to that. They alternate, of course. 4, 3, 4, 3. Height is 7, 7, 7, 7, 7. And then we have the box coming off of it. That's 3, that's 4, 3, and 4. If that's 3, that's 3, 4, 4, and 4. All right, and remember for the pyramid, I said draw the base first. 1, 2, 3, 4, 5. So 6. 1, 2, 3, 4, 5, 6. This is as hard as they'll get. Remember, I said it would be this or smaller. And then just draw your triangles off of it. Okay. So that's the pyramid. Now, the Euler's formula. So the first one was F plus V equals E plus 2. Other one is F plus V equals E plus 1. So let's look at this. Faces. There's the 6 going around in the base, so 7. Vertices. We got the 6 going around and up here, that's 7. Edges. Got the 6 here and then the 6 around, so that's 12. Plus 2, 14 equals 14, check. Now for this one, faces. 1, 2, 3, 4, 5, 6, 7, same as the other one. The vertices are, I'm just trying to get a different color that will show up. How about orange? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Equals edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 19 equals 19, check. Oh, I'm sorry. Urgh. There's the work for that. Okay. Now, last one I want you to try, and then shut this off and try, is this one, which is a little different than any you've seen. So it's going to be a good problem for you to do, and this will be the last thing we do. If I give you this picture, and I say I want you to revolve, picture it like a solid. You're going to revolve it around the y-axis. What's solid? What bigger, it's not a solid now, of course it's two-dimensional, but assuming that as you move it, it produces a solid, and you're rotating it around or revolving it around the y-axis, what solid do you get? So again, I want you to do that. Then once you figure that out, I want you to get the surface area in terms of pi, and I want you to get the volume in terms of pi. And then start this up again. Try it. I really highly suggest you try it and not just watch me do it. Okay, the answer should have been a cone, because as you turn it around, you're going to get this cone-shaped thing. Surface area of a cone, you'd get your formula down. Surface area is pi RL plus pi r squared, and pi r, oops, do I know the radius? Yep, I do. It's right here. It's 2. Do I know the slant height? That's right here. No. But I know the height. It's 4. Be careful you get the right numbers. Just because there's a 5 up there, don't grab the 5. You got to figure out how tall it is. And then you have Pythagorean theorem. So I can do 4 plus 16 equals L squared, 20 equals L squared, L equals square root of 20. Okay, so I figured that out, square root of 20, plus pi times the radius, which again is 2 squared. So I am going to actually, I should have broken this square root of 20 down first. Let's do that. I'll go over here and do that. Square root of 20 breaks down into square root of 4 and square root of 5. What is the square root of 4? 2. Square root of 5 does not break down. So instead of putting that in there, I should have put 2 root 5. All right, so let's simplify the best that we can do. So I've got this times this, and since they're all multiplied, I can do 2 times 2, which is 4, square root of 5, and then pi, that's that part, plus 2 squared is 4, pi, hang on one second, The Vikings are picking. Who they pick? Come on. Oh, they're not showing it. Okay. When you put these two together, you're going to add this plus this. So you're going to get 4 root 5 plus 4 all times pi. And the unit is, I don't know, so I'll put unit squared. That's a little tricky, isn't it? That didn't go together quite as nice as if this was just like 4 plus 4 is 8. You had to write it like that because you can't put those together. Volume is 1/3 pi r squared height. Volume equals 1/3 pi r is 2 squared and height is 4. So this is a little simpler. And that is 1/3 pi. 4 times 4 is 16. And now I got 6. Remember, I need it in terms of pi, so I can't be abbreviating this to 0.3. 16 over 1 times 1/3 is equal to 16 over 3 pi units cubed. And we're done. So there you go. I hope that helped you. I apologize that I was a little bit distracted. But I hope you, return back if there's other ones that you still had trouble with and try them again and see if you can get them. Okay, and we'll see you soon. Bye-bye.